Friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another popular Leetcode question 641, design circular cube. So this is a medium complexity popular coding interview question. So we are going to go through this problem. We are going to implement our my circular DQ class. As you can see, we have to implement all these couple of methods here in this class that will demo the circular DQ. So if you are new to this channel, please subscribe to this channel now. Your subscription is really important and valuable for us. It really helps and supports this channel. Here we create content to help others in their coding and Java interviews. So let's start. So design your implementation of circular double-ended DQ. Implement my circular DQ class, right? So my circular DQ int k initializes a DQ with maximum size of k. Okay, so that is the constructor. Then we have couple of methods. So first one is insert front. It returns boolean, adds an item in the front of the queue. Return true if operation is successful, false otherwise, right? Insert last is another method we will have to implement. It means that you are going to insert at the rear of the DQ, right? There are two ends. One is the front end and other is the back end, basically, which is the rear end, right? So insert last, you will insert the item at the rear of the DQ, true if it is successful, false otherwise. Delete front. So you have a front element, whatever is the front element, you want to delete that front element, right? So that is again true if it is successful, false otherwise. Deletes last, it's deletes from the rear of the DQ, returns true if successful, false, right? So delete last is another method. Get front will return front item from DQ. Get rear will return last item from DQ, returns -1 if the DQ is empty. Is empty will return true if your DQ is empty, and is full will return true if the DQ is full, right? So this is what the methods are. So this is the empty class that we will start filling in with our logic, right? And we'll start implementing this class. So the constructor, you have noticed that k is the maximum size of the queue, right? K is the maximum size of the queue. So what we will do here to implement this my circular DQ class is we will create one node class, right? And node will have three values. One is the value of that node. So this is how the node class will look like. So we'll use it and we'll use this class to implement it, basically, right? So you can visualize this circular circular list like like nodes which are attached to each other, basically, right? And here also some nodes in the middle, right? So this one will have a value inside it, and it will have two pointers, basically. One is the next pointer and one is the previous pointer, right? So always it will have a next and previous pointer. Each node will have two pointers, basically, right? Like this. Okay, like this, for example. And this is the front of the queue, right? This is the front of the queue, basically, front. And this one is the rear of the queue, right? Rear. So you can visualize this circular DQ as this one. So this node class we will create, and then we will start implementing those methods. I'll show you how to do that. So this is the same node class that we just saw, right? Three things: it has prev, next, pointers, and val, right? Okay, so couple of variables we will declare here. One is count. N is the maximum size of that queue. Count is your current size of the queue. Front node and rear node, right? So you will need these two nodes, correct? So this is the constructor my circular queue. So k is so this dot n is equal to k. So this is the maximum size that your queue can hold, and your count will be 0 in the beginning. Front and rear will be null in the beginning, right? Okay, so this is the constructor. So first method we will insert from front. Insert front is the method. So you can only insert front this value if um, uh, your circular DQ has space in it, right? If it is full, you will directly return false. I'll show you this is full method. So if your queue is full, then you will directly return false. That is first thing. Let's say you have a space now, then you have to create a brand new node, right? So you create a node, new node. If your front and rear both are null, it means that you don't have anything. Then your front and rear will become this new node, correct? in the beginning you don't have any front and rear. So in that case your front and rear will be this new node that we created here. Let's say you already have some elements, then what you will have to do, new node dot next is equal to front, because you are inserting this node at the front, right, at the front. So for example, right now my front is 1, let's say my front is 1. If I want to insert 100 here, right, 100 as my front element, if I am inserting 100 here, then what I have to do, this new node I created next should be my previous front, and the previous front should be the previous should be this new node, right? So that's what we will create here. So front dot prev is equal to new node, and front is equal to new node, and new node dot next is equal to front, right here. So these things you have to do. So you have to just, so what we are doing essentially, we are setting up those pointers correctly, right? And at the here you have to say that count plus plus, because you have added one more element to your queue, right? So count plus plus, you return true. So so this method returns boolean, right? So we are inserting it at the front here basically, correct? Okay, what if I am inserting it at the rear also is a possible, right? I can insert at the rear here. So that one is another method we will have to implement. So let's take a look at what the next method is, and then we will discuss this. So insert last, right? So insert last is the method we have to implement now. So I will again create a new node. This last, I will point this last dot next to this new node, and new node dot prev to this last node, right? And I will set up this one should be my new rear element basically, or node, right? So that exactly what we will do. Again, insert last. First thing always you will check when you are inserting is that your queue should not be full. If it is full, you will return false, otherwise you create a brand new node. If front and rear both are null, then front and rear will become the new node, correct? So this is common. Then a rear dot next is equal to your new node. New node dot prev is equal to rear, and rear is equal to new node. So exactly what we have seen here. So you are just again setting up those pointers correctly, increment the count and return true, right? Okay. Delete front. So you have a front element, right? Now you want to delete this element, then what you have to do? So you have to again set up the pointers correctly here. So again you will first, now when you are deleting, you have to always check that queue should not be empty, right? If queue is empty, you will directly return false. Otherwise, what you will check, if your front and rear are same, your front and rear are same, then you will just mark both of them as null, correct? Both of them should be null if they are same. Otherwise, what you will check, you will do front is equal to front dot next, because now front you are removing, right? So front should become front dot next, and front dot prev should be null, right? So you are, what you are saying that this was my front, now this is my front. So this previous should be null basically, because we are removing that, uh, deleting that node, right? So we are just marking it as null. Prev dot front dot prev is null, and front is equal to front dot next, count minus minus, because you deleted one node from the queue and return true, right? So this one happens when you are deleting from front. It is possible that you are deleting from rear, right? So this one you are deleting basically. So what happens in that case? You have to just go to this previous node, and its next should be null basically, correct? Its next should be null, and this one should become your rear, correct? So delete last. Again you will check the empty. If it is empty, return false. If front and rear both are same, then you will just mark front and rear to null in that case, right? Otherwise, what you will do, rear is equal to rear dot prev, right? Rear is equal to this, rear is equal to rear dot prev. So you are actually marking this node as my rear, because we are deleting this rear node, and then we have to set up that next pointer. Rear dot next should be null basically, right? And count minus minus, return true. So this is how you can implement delete last method. Get front is your queue is empty, you will return -1, because there is nothing in the queue. Otherwise you will just say front dot val, right? Front pointer is there, rear pointer is there. Get rear will do the same thing here, and you will just return rear dot val here. is empty. So if your count is 0, it means that your queue is empty, right? And if your count is equal to n, it means that your queue is full basically, right? So this is how you can implement these two methods. So this is pretty much it actually as far as the implementation is concerned. So this is the way you can write down this my circular Deque class using the node logic. um, so we'll just give it a run, make sure this code compiles and works correctly against the test cases. So as you can see, the test cases are getting passed with correct result, you can see here, and we'll submit this code now to the Leetcode, make sure the code gets accepted by the Leetcode. And as you can see here on the left side, the code is successfully accepted. This doesn't look right, so let's try to resubmit it because these numbers are not right, I think. So you can see here, this numbers is still not right. Sometimes it shows 100%, so I'm not sure about this thing. So this is the way you can solve this coding problem. It's on Leetcode number 641, design circular Deque. So the main important thing is this node class that we have to use. This is the internal class to this class that has three things. It has previous pointer, next pointer, and the value. And this is the basic logic that we discuss line by line, so that you completely understand all these methods that are there, right? So how to insert from front, insert from rear, delete from front, delete from rear, all those methods. So I hope you completely understood this problem with this explanation and examples. And if this video helped you understand this implementation in Java of a design double-ended circular Deque, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is really valuable and important for the channel. It really helps and supports this channel. It takes lots of efforts to create these examples and videos for you guys. So if you really want to appreciate these efforts, then try to be generous. Give it a like to the video if this video helped you understand this problem. Click on the bell notification icon button right away, so you will immediately get notifications for our interesting upcoming videos here. And click on the subscribe button so that you can subscribe to our channel. Uh, if you're planning to take any new interview rounds, or you want to learn more computer science related concepts, that the important playlist that you should not miss from this channel includes graphs, matrices, binary search trees, binary trees, how to solve different problems using binary search, recursion, dynamic programming, memoization, how to use and apply BFS and DFS on graphs, matrices, and trees. There are important playlists for data structures such as stacks, queues, priority queues, min heap, and max heap. So don't forget to check out those important solved problems. They will give you good preparation for your interview rounds and will help you learn more about computer science fundamentals, concepts, data structures, and algorithms. Keep learning, keep coding, keep solving more varieties of coding problems. And thanks for watching this video and have a great day ahead.